Bismillahirrahmanirrahim. Dear students, have a nice day. Hope you will be fine best of your health. This is Dr. Sajid Mahmood Rao, Division of Science and Technology, University of Education, Lahore. Today we are talking about a brief overview of the natural products, its applications and pharmaceutical commercializations for the same. Let's see what are the natural products. Natural products are the organic compounds produced by the living organisms, plants, insects, marine organisms, and marine animals. Different kinds and classes of the natural products are produced within these sources. Literature survey shows that more than 300,000 plants have been reported, but only 3% of these plants are subjected for the structural elucidations of the target compounds. In Pakistan, God has gifted with enormous varieties of medicinal plants, but only 20% of these medicinal plants have been evaluated for their therapeutic effects. So, there is a need of coordinated and well-organized work in the field of natural product chemistry. Natural products are used in our daily lives, breakfast, lunch, and dinners. Similarly, most of the natural products are used in the formulations and evaluation of pharmaceutical dosage form that includes nutraceutical food supplements, Ayurvedic products, and pharmaceutical drugs. More than 50% of the pharmaceutical drugs have their origin from the natural product chemistry. This is the schematic presentation of the natural products, which gives information how the natural products are commercialized into pharmaceutical dosage form on the basis of in vitro and in vivo studies and on the basis of phytochemical screening. So you can see in the first step, the plant is collected on the basis of availability of the plant. Literature survey report which gives information that either no work has so far been carried out on this genus and species. Third, biological, enzymatic and pharmacological importance. The next step is plant identification. In this step, the plant is submitted to the botanist, which confirm its genus and species and allow us for further process. The next step is shade drying. Here, the whole plant material is placed in shade for drying purpose, which may take some weeks or some months. The next step is chopping and grinding. In chopping and grinding, the whole plant material is chopped and grinded by using pestle mortar or by using crusher and grinder. The next step is soaking. In this step, the powder material of the plant is dipped in methanol by using methanol polar organic solvents because our target is to extract maximum number of phytoconstituents from less to high polarity. The next step is filtration. The filtration is carried out by using Whatman paper or simple paper or porcelain cloth. Here we get the final methanolic extract in the form of filtrate. The methanolic extract is now converted into solid mass by using rotary evaporator. The next step is fractionation. Here in this step, distilled water and methanol is added in the solid mass to get two layers in organic solvents. Fractionation is carried out by using organic solvents, and that organic solvents are n-hexane, chloroform, ethyl acetate and butanol. So here in fractionation, we get four different fractions on the basis of organic variety system, and that fractions are n-hexane fraction, chloroform fraction, ethyl acetate fraction, butanol fraction and aqueous fraction. Now all the fractions are subjected to phytochemical screening. Phytochemical screening is a qualitative analysis which gives information about the secondary metabolites and confirm how many and which kind of the secondary metabolites are present in each fraction. On the basis of phytochemical screening, now the fraction which have maximum number of phytoconstituents and secondary metabolites are subjected to in vitro and in vivo studies so that we can search more active fractions in the sense of biological active, enzymatic active and pharmaceutical importance fraction. Here this fraction is further selected for the column chromatography. In column chromatography, column silica is used as a stationary phase and different combinations of the organic solvents are used as a mobile phase. This technique is used for the isolation and the separations of the organic compounds or the phytoconstituents on the basis of the organic polarity system. The next step is thin layer chromatography. This is a technique which is used to confirm the purifications of the compounds. This technique is carried out by using the different combinations of organic solvent. If we have a single compound upon our TLC card, it means the compound has been pured. Now, this compound is submitted for the spectral techniques, which includes IR, MAS, proton NMR, C13 NMR, HMBC, HMQC, NOE, COSY, and MALDI techniques. All these spectral techniques are useful for the structure elucidations and the structure terminations of the organic molecules. Now, the next step is nutraceutical, Ayurvedic, and pharmaceutical dosage form. Here in this step, the more active phytoconstituents and active crude herbs are subjected for the formulations and evaluations of nutraceutical, Ayurvedic, and pharmaceutical dosage form. In the next step, different kinds of excipients are used as a preservative and flavoring agent, which are used for the purpose of taste masking and giving the shape and giving the weight of the organic pharmaceutical dosage forms. So you can see in the final step, the pure active phytoconstituents as well as crude herbal extract, which is more active, both are subjected for the formulations and evaluation of the pharmaceutical dosage form. And these pharmaceutical dosage form may be syrup, capsule, sachet, suspension, and tablet dosage form, which are commercialized on the basis of activity ingredients. Finally, you can see here the pharmaceutical finished products from herbal extracts and phytoconstituents. These pharmaceutical dosage form are tablet dosage form, capsule dosage form, and syrup dosage form. All these three pharmaceutical dosage form are more appropriate and have more marketing values. Natural product chemistry is at the intersections of many fields that include ecological biochemistry, taxonomy, entomology, combinatorial chemistry, chemical synthesis, microbiology, molecular biology, biotechnology, biochemistry, and pharmaceutical sciences. So these fields interlinks with the natural product chemistry. Now come to the real topic, that is alkaloids. When we see the statement of these molecules, we observe all the phytoconstituents that have nitrogen atom within the heterocyclic ring system, generally known as alkaloids. These are the secondary metaboloids. Secondary metaboloids are those substances which are used for the cure and treatment of different diseases, and these can be taken on demand. The primary metabolites are those substances and chemicals which are very necessary for the development and the reproductions of the living cells. So, the secondary metabolites are not necessary for the development and the productions of the living cells. When we see the structures of these molecules, you can see the caffeine, which have 4 nitrogen atoms in the molecule. The 2 nitrogen atoms are present within the hexacyclic ring and 2 nitrogen atoms within the pentacyclic ring. In the second molecule, that is nicotine, in the nicotine 1 nitrogen atom is present in the aromatic ring and the other is present in the 5-member ring. The third molecule is ephedrine. Ephedrine does not include in the genuine alkaloids molecules because the nitrogen atom is present outside the ring system. However, the physical characteristics are generally similar to those of the alkaloid molecules. The alkaloids are soluble in organic solvents, but their salts are all soluble in water and alcohols. You can see here the identification tests of the alkaloid molecules. These tests are performed by using different reagents, and 2 tests are performed for the identification of alkaloid molecules, that was Mayer's test. In the first test, the Mayer's reagent is prepared by using mercury chloride that is taken as 1.36 gram and potassium iodide that is taken as 5 gram, and both these reagents are dissolved in the water and the volume make up to the 100. Now the sample is dissolve in few drops of the mere reagent, and we observe the creamy colored precipitates, which indicates the presence of alkaloid molecules. The second test is Wagner test. Wagner's reagent is prepared by taking 2.5 gram of iodine and 1.25 gram of potassium iodide. Both these reagents are dissolved into 50 ml of water and make up the volume up to the limit. Now the sample is taken with few drops of Wagner's reagents and we get the red-brown precipitates, which indicates the presence of alkaloid molecules. Alkaloid molecules are isolated from different sources that include different species of the plants. For example, the papaver is isolated from Papaver somniferum, nicotine from Nicotiana tabacum, and caffeine is isolated from Coffea arabica. Alkaloids molecules have different pharmaceuticals and biological activities. You can see here different kinds of phytoconstituents that have different kinds of biological activities. That includes morphine and codeine that have analgesic activities, ephedrine that have anti-asthmatic activities, quinine is used as anti-malaria drugs, and atropine is used as mydriatics drugs. Different kinds of the phytoconstituents are present within different species of the plants. You can see in the below structures that is ephedrine, and ephedrine is used as anti-asthmatic plants that is isolated from the ephedra plant. The next molecule is nicotine. In the structures of nicotine, we have two nitrogen atoms within the heterocycle ring, and it is used as addictive drug. Caffeine is used as CNS stimulant. In the caffeine structures, four nitrogen atoms are present within the heterocycle ring system, two are within the hexacyclic ring, and two are present within the pentacyclic ring. Now we will discuss the applications of the alkaloid molecules. First of all, we will discuss the medicinal applications. You can see the caffeine is a phytoconstituent which is used as CNS stimulant. Morphine is used as analgesic drug. Quinine is used as antipyretic and antimalarial drug, and cocaine is used as psychoactive drug. The last phytoconstituent, that is mescaline, it is used as hallucinogenic effect. Alkaloids phytoconstituents can also be used in the field of fertilizers. You can see the low toxic pesticides such as nicotine and ampicillins are used in the field of fertilizers. It can also be used in limited amounts because they are highly toxic for humans. You can also see the phytoconstituents of alkaloids are used in the food industry. For example, cocaine, caffeine in cocoa, in chocolates, in tea and coffee. Similarly, tropane, piperine and nicotine are used in the modern food chains. Now we will discuss the nutraceutical forms, means which kinds of the phytoconstituents and the crude herbs are commercialized into different brand of the pharmaceutical sectors. The name of this brand is Caffeine Power. It is manufactured by the high-tech pharmaceuticals. The dose which we can take, that is 200 milligrams, and one tablet can be used every 3 to 4 hours. This brand is formulated in tablet dosage form, which is used serving per container 100 tablets. It is used to stimulate central system. The next brand is LGND, which is manufactured by the Inspired Nutraceuticals. We take 100 milligrams per capsule. It is formulated in the capsule dosage form, which have 4 capsules before exercise. It is used. So you can see here this brand is formulated in the tablet pharmaceutical dosage form, which is used serving per container 100 tablets. It is used to stimulate central nervous system. The next brand is LGND, which is also manufactured by the Inspired, and we take 100 milligrams per day. It is used 4 capsules before exercise. This brand is formulated in the capsule dosage form, which is serving per container 120 capsule. It is used to reduce stress and anxiety, enhance sports performances, increase muscular mass and strength, and improve thyroid functions. The next brand is also manufactured by the Inspired. The name of that brand is 3MB3R. Week and 300 milligrams per day is potency, and its pharmaceutical dosage form is sachet. It is used in fat loss, increasing lean mass, boosting metabolism, enhancing exercise performance, and promoting cardiovascular health. Let's see what are the steroids. Steroid is also a secondary metabolite, which is generally known as lipids. Steroids are soluble in organic solvents and insoluble in water. Different kinds of the organic solvents are used for the isolation and extractions of the secondary metabolites. And these organic solvents are methanol, butanol, ethanol, ethyl acetate, chloroform ether, benzene, and N-hexane. So, the lipids so obtained are of two categories. One on sonification gives water soluble matter, and other on sonification do not give water soluble matters. These kind of substances known as steroids. Steroid is the Greek word which has been derived from the word stereos, which means solid. The basic skeleton of the steroid molecule consists of four membered rings, in which three members are hexagonal and the fourth ring is pentagonal. So we can say that the steroid basic skeleton consists of two units. One unit is called cyclopentane unit and the other unit is known as phenanthral unit. Steroids includes wide range of naturally occurring compounds like sterol, cholesterol, bile acids, sex hormone, adrenocortical hormones, cardioglycosides, sapogenins, and alkaloids. In these molecules, sometimes the steroid molecule is linked as a substituent. So we can say that if the steroid molecule is linked with the alkaloids, we call that molecule as a steroidal alkaloids. Similarly, if the steroid molecule is linked with the sapogenins, we call it as a steroidal sapogenins. The said above naturally occurring compounds have functions in human physiology, biological importance, as well as enzymatic activities. Nomenclature of steroid molecule. In the beginning, there is no any systematic way to give the name of the steroid molecules. However, it was decided in the conference that has been held in London at SIPA Foundation in 1950s. In this conference, it was decided that the names are given on the basis of sources and on the basis of the carbon skeleton of the steroid molecules. It was also decided for the first time that the four rings of the carbon of the steroid molecule should be labeled as A, B, C, and D. You can see in the structures the rings has been labeled as A, B, C, and D, and the total number of carbon atoms present within this molecule are also mentioned. The total number of carbon atoms in these molecules are 17. On the basis of the total number of carbon atoms and their sources, the name of this molecule was given as guanine. Let's see some important steroidal compounds and its pharmaceutical applications. In the first molecule, the total number of carbon atoms are 17 and the name of this molecule is guanine. This molecule has been isolated from Solanaceae and Melanthaceae family of the plants, and it is used as a contraceptive vaginal rings. Also, it is used in progestational activity. This molecule is soluble in organic solvents such as ethanol, acetonitrile, and methanol, which should be purged within an inert gas. The second molecule consists of total number of carbon atoms are 18, and the name of this molecule is astrane. In this molecule, you can see that there is an additional methyl groups at carbon 13, and so we can say that this is the derivative of the guanine molecules. The astrane molecule is obtained from estrogen steroid hormones and biotransformations of the Pseudomonas aeruginosa, and also from corn oil extraction. The solubility of this molecule is in chloroform, DMSO, and methanol. It is used in active metabolites for the treatment of amenorrhea, abnormal uterine bleeding, as well as for the prevention of the pregnancy. In third molecule, the total number of carbon atoms are 19, and the name of this molecule is androsten. In this molecule, there is a presence of two methyl groups at carbon 10 and carbon 13 position. Androsten was obtained from Cooley's plant and ephedra, and it is used for the treatment of asthma and as an anti-inflammatory activity. This molecule is soluble in acetone, isopropanol and benzene. In fourth molecule, the total number of carbon atoms are 21. The name of this molecule is pregnine. This molecule is found in the urea as a metabolic product in the form of 5-beta-pregnane compounds. We can extract pregnane glycosides from Labradenia pyrectotechnica plants. This molecule is soluble in DMSO and ethanol. This molecule is used for genes regulation transcriptions as well as drug metabolizing enzymes in the liver and intestine. The fifth molecule consists of total number of carbon atoms 24, and the name of this molecule is choline. This molecule was isolated from the bile secretions of American bulldog, and it is soluble in ethanol, DMSO and dimethylfuramide. This molecule is used in its acidic form as an antimicrobial and antifungal activity in various diseases. In sixth molecule, the total number of carbon atoms are 27, and the name of this molecule is cholesterol. Cholesterol was isolated from petroleum deposits and also in rhodophyte. This molecule is soluble in isopropyl alcohol, ethanol, methanol, acetone and chloroform. This molecule is used for the treatment of advanced and metastatic cancer and also used in apoptosis and necrosis. In this slide, we will discuss 5 more organic steroidal molecules, their uses and pharmaceutical applications as well as their isolation. You can see on 7 number, the name of this molecule is ergostane. The total number of carbon atoms in these molecules are 28. This molecule is isolated from Solanaceae and Leguminosae family, especially from the Thura plants, and it is soluble in carbon tetrachloride and methanol. This molecule is used as a biomarkers of eukaryotes. The next molecule is stigmastane. Total number of carbon atoms in these molecules are 29. Stigmastane is isolated from Alcornia floribunda leaves and roots of Ipanigrum. This molecule is soluble in chloroform, DCM, DMSO, acetone and ethyl acetate. This molecule is used as anti-inflammatory, used in the biomarkers of early eukaryotes. The next molecules on 9 number is cardenolide. Total number of carbon atoms in cardenolide are 23. Cardenolide is isolated from Apocynaceae and Moraceae family, as well as it is found in butterflies and sugar lactone derivatives. This molecule is soluble in diethyl ether and methanol. It is used as anti-leukemia agent and toxic in stent heart arresting. It inhibits potassium and sodium ions concentrations in and out of the membrane. The next complicated molecule is pyrostane, which consists of total number of carbon atoms is 30. This molecule is isolated from white onion and red onion and soluble in ethanol, trichloromethane and chloroform. Pyrostane is used as antifungal pathogens like Penicillium italicum, Aspergillus niger. The last molecule is bufenolide. Total number of carbon atoms in bufenolides are 24. Bufenolide is isolated from Toadvenum, ethnomedicinal plants of the Kalanchae genus, and it is soluble in methanol and chloroform. It is used in severe colic conditions, in vigorous and in depression. Now, we will discuss in the next slide the IUPAC name of the steroidal molecules. This topic is relevant to the IUPAC names of the steroidal molecules. So, in this slide, we will learn how can we give the name of the complicated steroidal structures. The IUPAC approved most of the rules with style modifications we will discuss here. It consists of 8 rules. Now, we will discuss these rules one by one. Rule 1. Prefixes and suffixes are added to the parent hydrocarbons indicating the nature of the carbon atoms. Rule 2. The position of substituents indicate the number of the carbon atom to which it is attached. Rule 3. When more than one substituents are present in the same molecule, only one is indicated as suffix and the remainder is indicated as prefixes. Rule 4. The substituents to be chosen by suffix is given by the priority order as given below. Means, if you have more than one suffix substituents, then how can we decide which should be the first as a superior suffix and the other should be used as prefixes? The order is given below: carboxylic acids, lactones, esters, aldehydes, ketones, alcohols, amines and ether. Rule 5. Alkyls, halogens and nitro groups are always shown as prefixes. Rule 6. The degree of unsaturation is indicated by the suffix "-ine". Rule 7. The locations of the carbon-carbon double bond is specified by giving the lesser of the two numbers of the carbon in the double bond and "-ane" is converted into "-ine". Rule 8. When double bond lies between two carbons which are non-consecutively numbered, both numbers are given but the greater number is given in the brackets. For example, if we have unsaturations at carbon 8 and carbon 14, then we will write these unsaturation in the following way: the greater number is 14 and will be written within the brackets, and the lesser number 8 will be written outside the bracket. At the end, we will write it as "-ine". This table would definitely be helpful to give the IUPAC name of the steroid molecules, because in this table I will let you know which kind of the substituents should be used as prefixes and which kind of the substituents should be used as suffixes. In the table you can see, if we have olefinic double bond always taken as suffix, so it can be written as "-ene". If we have triple bond in the steroidal structure, triple bond will always taken as suffix and it can be written as "-yne", wine. If we have acetate substituents in the steroidal molecule and we take it as prefix, it can be written as acetoxy. And if we take this molecule as suffix, it can be written as "-vinyl acetate". If we have hydroxyl group in the steroidal structures and we take it as prefix, it can be written as hydroxy. And if we take it as suffix, it can be written as "-ol". If we have benzoate hydroxyl group, benzoate group in the steroidal structures and we take it as a prefix, it can be written as "benzoloxy". And if we take it as suffix, it can be written as "-vinyl benzoate". If we have carboxyl group in the steroidal structures and we take it as prefix, it can be written as "oxo", and if we take it as suffix, it can be written as "-one", on. If we have carboxylic acids in the steroidal molecules and we take it as prefixes, it can be written as carboxy. If we take it as suffix, it can be written as oic acid. If we have carboxylic acid or methyl esters in the steroid molecules and we take it as prefixes, it can be written as carbonate or methoxy. If we take it as suffix, it can be written as methyloate. Epoxides and halogens are always used as prefixes and it can be written as epoxy and chloro respectively. If we have amine substituents in the steroidal molecules and we take it as prefix, it can be written as amino, and if we take it as suffix, it can be written as amine. You can see here two examples that is relevant to the IUPAC names of the steroid molecules. In the first example, the total number of carbon atoms are 19 and the name of this molecule is androsten. By using IUPAC rules, we have given the name of this molecule as 6-beta-17-alpha dihydroxy androst 4-3-on. Now, in the second example, the total number of carbon atoms are 27 and the name of this molecule is colistin. Yes, students, now you will give the name of this molecule by using the IUPAC rules, and this is your assignment. These are the practice tips which would definitely be helpful to give the name of the steroidal molecules. However, first you should collect all the data on a separate page and then use that data for giving the name of the steroidal molecules. Now we will discuss these practice tips one by one. Number 1. Count numbering or identify their stem skeleton. For example, you have total number of carbon atoms on the steroidal molecule 17, the name of that molecule will be guanine. If you have total number of carbon atoms within the skeleton 18, the name of that molecule will be astrine. Similarly, if we observe the total number of carbon atoms within the basic skeleton of the steroid molecules are 19, the name of that molecule will be androsten. So, in this way, we select the basic skeleton of the steroidal molecules. Number 2. Count prefixes, substituents as alkyl or halogens. Number 3. Count suffix substituents, say 2 or 3. Number 4. If we have 2 or 3 suffix substituents, then we will comparison between these two suffix substituents. For example, if we have keto group and a hydroxyl group within the basic skeleton of the steroid molecules, we comparison them and select which one is the priority order. Here in these two groups, the keto group is on the superior priority, so it will be used as suffix, and the hydroxyl group will be considered as prefixes. Number 5. Identify their stereo as alpha and beta positions, means how many substituents or the functional groups are present at alpha or beta positions of the carbon atoms within the steroid molecules. Number 6. Count unsaturation as 2 or 3 or more, means how many total number of double bonds are present within the steroid molecules, and also check how many double bonds are consecutive and how many double bonds are non-consecutive. If we have consecutive carbon atoms, say the double bond is present at carbon 4 position or at carbon 4 and 5 position. If we have a single double bond at carbon 4 position, then it will be written within the brackets as 4-ene. And if we have two double bonds at carbon 4 and carbon 5 positions, and both these double bonds are consecutively numbered, so these will be written as 4,5 diene within the brackets. And if we have non-consecutive carbon atoms, say the double bond is present at 8 positions and 14 positions, so the greater number will be written within the brackets and the smaller number will be written outside the brackets, and at the end we will be written it as diene. In this slide, I will let you know about the sequence to give the name of the steroidal molecules. So, first, write all the prefixes substituents and mention their position. Second, give the name of the stem skeleton. Third, give and write the unsaturations. Fourth, give the name of the suffix substituents. In the example, you can see we have androsten molecule and the total number of carbon atoms are 19. In these molecules, we have 3 substituents at carbon 3 position, carbon 6 position and carbon 17 positions. Now, first of all, we will comparison it because all the 3 groups are suffix, and we want to choose which one is the suffix and which one is the prefix substituents. Since keto group at carbon 3 position is senior as compared to hydroxyl group, so keto group will be selected as suffix substituents and all the other will be written as prefixes substituents. So the name of this molecule will be written as 6-beta 17-alpha dihydroxy. Dihydroxy means we have 2 hydroxyl group at carbon 6 and 17 positions. And roast means this is the basic skeleton, means how many total number of carbon atoms present in these molecules. Then 4-ene. 4-ene means there is the presence of double bond at carbon 4 position, and at the end 3-one. 3-one is a suffix and this is mentioned at carbon 3 position and will be written as suffix molecule. Dear students, now you will give the name of the coelestain molecule by using all the IUPAC rules and all the practice tips, as well as use this type of sequence. Dear students, have a good time. In the previous lecture, we have learnt about the introduction of the steroidal compounds, its common structure, pharmaceutical applications and IUPAC name. In this lecture, we will discuss about the physical characteristics, classifications of the steroids, as well as identification test or the phytochemical screening of the steroidal compounds. Let's see the physical properties. Most of the steroids are solid in nature and their melting points fall in the range 100 to 250 degrees centigrade. But few are exceptional cases like coprostane. The melting point of coprostane is 63 degrees centigrade. The other molecule, that is 5-alpha theanine, 3-beta, 16-alpha, 20-beta thiol, have melting point 304 degrees centigrade. So these are the two molecules which have their melting point above and below the general range of the melting point of the steroidal molecules. The melting points are sensitive to the small amount of impurities. Some steroids are crystallized upon melting point on the different solvents. Other steroids have ability to form liquid crystals during melting points. The solubility of the steroid molecules, you can see, steroids are generally soluble in organic solvents and insoluble in water. The organic solvents which are used for the solubility of the steroidal compounds are petroleum ether, benzene, acetone, and ethanol. In this slide, we will discuss the basic structures of the sterols molecules, their classifications, and their identification test. Sterols are those steroidal molecules in which hydroxyl group is present at carbon 3 positions, and generally these consist of carbon 27 to carbon 30 basis skeleton of the carbon atoms. So sterols are 3 monohydroxy steroids having carbon 27, carbon 28, carbon 29, and carbon 30 basis skeleton. They are crystalline in nature, widely distributed in nature, and occur both in free as well as ester of higher aliphatic acids. All sterols have 3-beta hydroxy group and also 1 or more double bonds. The most common position of double bond is carbon 5, carbon 22, and carbon 7. Classifications of the sterols. Based on occurrence, the sterols are classified as follows. Zoosterols. Zoosterols are those sterols which are isolated from animal sources. The common example of these sterols are 5-alpha cholesterol, 3-beta-ol. Other example is 5-beta cholesterol, 3-beta-ol. Number 2, phytosterols. Phytosterols are isolated and extracted from the plant sources, and the common examples of phytosterols are stigmasterol, camptosterol, and cetosterol. Number 3, mycosterols. Mycosterols are extracted and isolated from the yeast and fungi sources, and the common examples of these sterols are ergosterol and ergocalciferols. Number 4, marine sterols. Marine sterols are extracted and isolated from the marine organisms, and the common example of these sterols are dinosterols, which are found in dinoflagellates. Number 5, higher animal sterols. These sterols are isolated from higher animals, and the common example of these sterols are cholesterol 27. Here in this slide, we will discuss some important identification tests and color reactions which are useful to determine sterol structures by dehydrations and salt formation. Generally, strong acids are used. The first reaction is Lieberman-Butcher reaction. In this reaction, the sample is taken in chloroform and few drops of concentrated sulfuric acid is added along the side walls of the test tube. Then added acetic anhydride and we observe green color. If the color is observed after 30 minutes, it means it is positive test for sterols and the double bond is present at carbon 5 position. If the color is appeared after 1.5 minutes, it means it is positive test for stenols and the double bond is present at carbon 7 position. Sol-Bisky reaction. In this reaction, the sample is taken in chloroform and added few drops of concentrated sulfuric acid. If we observe red color in chloroform layer and green color in sulfuric acid layer, that is aqueous layer, then this is positive test for the cholesterol. Third test, that is Rosen-Heim test. In this test, sample is taken in chloroform plus 90% trichloroacetic acid is added in few drops along the wall of the test tube and we observe blue color or pink color, then it is positive test for the sterols. Number 4, Lipase test. In this test, the sample is taken in chloroform plus added perbenzoic acid and glacial acetic acid. In this test, Few drops of concentrated sulfuric acid is added along the side walls of the test tube. At the end, we will observe intense blue color or green color. It means this is positive test for sterols. Number 5. Fischer test. In this test, sample is taken in chloroform plus added selenium dioxide or benzene and heated it at 20 degrees centigrade. We observe the yellow color. If we observe yellow color, it means this is 5 alpha series sterols, and if we observe no color, it means it is 5 beta series sterols. 5 alpha and 5 beta means there is the presence of hydroxyl group at 5 alpha positions and there is the presence of hydroxyl group at 5 beta position. So this test is positive for 5 alpha series. Number 6. Tortelli-Chaff test. In this test, sample is taken in acetic acid and added 2% chloramine solution in chloroform. We observe green color. This is positive test for the sterol. Next, we will discuss the structures of carbon 27 to carbon 30 sterols. The first structure is carbon 27 sterols. In these structures, the molecular formula of this structure is carbon 27 H46O. The specific rotation is -40. These type of sterols are found in the matter in human brain and 0.05% to 5% in our tissues. It is isolated from the spinal cord and brain of cattle, and it is used for the synthesis of vitamin D3, steroidal hormones, and bile acids. These are the examples of carbon 20 sterols, that are cholesterol, zymosterol, and desmosterol. Cholesterol is used as a major component of all cell membranes. It is used to make essential molecules such as hormones, vitamins, and bile acids. The zymosterol is used as an intermediate of cholesterol biosynthesis, and it is very important role as a human metabolite. The third molecule, that is desmosterol, a molecule similar to cholesterol, and it is used to diagnose Alzheimer's diseases. Carbon 28 sterols. When we see the occurrence of these sterols, these are isolated from archaeogetes, fungi, algae, vegetable oils, lichens, and egg yolks. The significance of these sterols are: it is used for the synthesis of vitamin D2, it is used as a byproduct in fermentation. These sterols are used in industrial sectors, as well as these are used for the biosynthesis of progesterone and adrenocortical hormones. The common examples of carbon 28 sterols are ergosterols and ergocalciferols. Ergosterol is used as an antifungal agent, and it is used in West Africans for sleeping sickness. Ergocalciferol is used to treat parathyroid glands. It is used in rickets diseases caused by vitamin D deficiency. Ergocalciferol is used in hypophosphatemia, that is low level of phosphate in blood. Carbon 29 sterol. When we see the occurrence of these sterols, these are isolated from higher plants as esters and glycosides. These can also be isolated from caliber beans, soya bean, and sugar beans. The significance of these sterols are in the synthesis of steroidal hormones and progesterones. The common example of carbon 29 sterol is stigmasterol. Stigmasterol is used to reduce risk of cardiovascular diseases. It is used as anti-tumor, antioxidant, and anti-inflammatory agent. It can be used in CNS diseases. Carbon 30 sterols. When we see the occurrence of these sterols, these are isolated from higher plants, herbs and shrubs, and the plant Salvia centralinifolia. The significance of these sterols are: these are used as antiseptic, enzymatic activity, these have spasmolytic activity, these are used against heart diseases in angina pectoris as well as amenorrhea and dysmenorrhea. The common examples of these sterols are 1,2,8-trimethylphenanthine and lanosterol. The lanosterol is used in eye drops to treat eye diseases. The common brand of these eye drops is Lanomax. Dear students, these are some important assignments and quiz which you would have to submit within 7 days after the delivery of first lecture. The first assignment is that explain isolation, separation, purification, and structural elucidation of ergocalciferol, stigmasterol, and progesterone. The second assignment, write a note on 6 herbs that are useful to increase the progesterone level in women. Also write the name of phytoconstituents that are responsible for the production of progesterone. Third assignment, draw schematic presentations of steroidogenesis. Fourth assignment, discuss the importance of in vitro and in vivo studies with reference to commercializations of crude herbs and phytoconstituents. Dear students, thanks so much for your kind attention. In the next lecture, we will discuss about the classifications, pharmaceutical applications, and isolation and purifications of the natural products of other classes.